بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. It's a lecture of Pharmaceutics 2, PT 404. Hi everybody, I'm Professor Dr. Wana Awalanin, and this is my office hours and my office place. This is my email, and of course you can use it to send your questions anytime. These are reference textbooks and recommended one of our course. Yeah, let's start our lecture. We were discussing formulation of ointments, and we said that to choose a suitable base, you should know types of ointment bases. That there are 4 types of ointment bases. We discussed oleaginous bases and absorption bases. What about water-miscible bases and water-soluble ones? For water-miscible bases, the water behavior of the base is oil in water emulsion. This means that during preparation of the base, I myself put water in the composition of the base. The base is oil in water emulsions. And actually, all the properties of the base will be due to its water content in the external phase of the emulsion. This is what about water content during preparation. What about the behavior of the base due to water? This base can hold very high amount of water. It can hold more than 70% its weight water. So the water number of water miscible bases is relatively very high. Advantages of these bases, they are suitable for water soluble drugs because, as we said before, when you use a base for a certain drug, you should use a base with the external phase that can dissolve the drug. This external phase is water in water miscible bases, so they are suitable for water soluble drugs because here drugs will be in the external phase. They are easily removed due to the presence of water in the external phase, so they can be applied to hairy parts. They are not occlusive because the oleaginous the substance content is relatively smaller than other bases. Because they are not occlusive, they can be applied to areas with exudates. They are of good appearance and they promote drug absorption, and these 2 advantages we said before in discussing oil in water type of creams. Also, oil in water emulsions in water miscible base have good appearance and promote drug absorption due to the presence of water in the external phase. The main composition of water miscible bases, of course, you will find oleaginous substance. This oleaginous substance serves to control viscosity. Then you will find an emulsifying wax. And as we said before, emulsifying wax produces oil in water emulsion. And then you find water. Emulsifying wax, examples of emulsifying wax. We said before that emulsifying wax is produced due to the reaction between cetostearyl alcohol and emulsifying agent. This emulsifying agent may be sodium lauryl sulfate or cetrimide or macrogol. As we know from surfactants in the cream part, sodium lauryl sulfate is an anionic surfactant. Cetrimide is a cationic one and macrogol is a non-ionic one. The reaction between cetostearyl alcohol and sodium lauryl sulfate produces sodium lauryl sulfate emulsifying wax, or simply called emulsifying wax, and this is an anionic emulsifying wax. Reaction with cetrimide results in cetrimide emulsifying wax, which is cationic emulsifying wax, and reaction of cetostearyl alcohol with macrogol results in the formation of cetomacrogol emulsifying wax, which is a non-ionic emulsifying wax. So, as an example for the water miscible base is the emulsifying ointment mentioned in the British Pharmacopoeia. Emulsifying ointment contains paraffin oil, Vaseline, emulsifying wax, and of course water. Paraffin oil and Vaseline are the oleaginous substance that are used to control viscosity of the base, and the emulsifying wax is the oil in water emulsifier. Actually, there are different types of this emulsifying ointment. The type which when you use sodium lauryl sulfate emulsifying wax, or simply called emulsifying wax, is called emulsifying ointment. British Pharmacopoeia is included in the British Pharmacopoeia. The same base may be prepared but using cetrimide wax, and in this case it will be named cetrimide emulsifying ointment according to the British Pharmacopoeia, and may also be prepared using cetomacrogol wax, and in this case British Pharmacopoeia called this base cetomacrogol emulsifying ointment. These are examples of water miscible bases: emulsifying ointment, cetrimide emulsifying ointment, cetomacrogol emulsifying ointments. All of them are composed of oleaginous part, paraffin oil and Vaseline, used to control the viscosity of the base, and an emulsifying wax, either sodium lauryl sulfate emulsifying wax, cetrimide emulsifying wax, or cetomacrogol emulsifying wax. So we have to discuss water-soluble bases. What about the water behavior of water-soluble bases? Water-soluble bases have unique properties. All ingredients of this base are water-soluble. Water-soluble? Yes, there is no fat in this base. It is all only composed of oleaginous substance. And as you remembered, oleaginous substance is a non-fatty substance. It's not a fat, but it resembles fats in one property. They can be melted at relatively suitable temperatures, and they congeal at room temperature. يبقى ingredients of water-soluble bases are not fats, but they are oleaginous substances. They are even soluble in water, but they are not fats. So this base is called greaseless base. It is not greasy because it doesn't contain fats, but it contains water-soluble ingredients that can be melted at relatively suitable temperature and congeals at high temperature, so they are suitable to be used as an ointment base. Advantages of water-soluble bases: they are compatible with many drugs. They are chemically and microbially stable. They are chemically stable because during preparation we do not add much water in this base, as we will see later on. They are microbially stable because they are of synthetic origin, not natural origin. They are easily removed because they are soluble in water. So they can be applied to hairy parts. As we said, they are greaseless, so they can be applied to areas with exudates. But this base has a very important disadvantage. What is this? Because all ingredients are water soluble, this base cannot hold much water during preparation. You cannot add much water during preparation. Only 5% of base weight water you can add. But if you need to add water to this base during preparation, don't add much water. Just add 5% of the base weight. Why? Because the ingredients of this base are soluble in water. So when we add much water during preparation, ingredients will dissolve in water, giving a solution, not an ointment base. When you use water-soluble base as an ointment base, you can add only 5% water, 5% of the base weight during preparation. Water-soluble bases have good solvent properties for drug. طيب, is this an advantage or a disadvantage? It's an advantage in being a cause for facilitating formulation. Good solvent properties of water-soluble bases makes formulation of ointment easy, makes preparation of ointment be easy. All substances are soluble in this base, but بيبقى البريباريشن أسهل بكتير. But it has a disadvantage. What is this disadvantage? Water-soluble bases cause poor release of the drug. Poor release of the drug? Yes, this means the amount of drug release is very small. Why? Because the drug is soluble in the base, is highly soluble in the base. So the drug prefers to stay soluble in the base, not to release to the surface of the skin. كل ما الدرug كان more soluble في البيز, كل ما amount, take care, I'm talking about amount released of the drug, هتبقى أقل. The higher the solubility of the drug in the base, the smaller amount that can be released. ليه؟ علشان الدرug prefers, بيفضل انه يقعد في البيز اللي هي دي فيها high solubility عن انه to be released ويخرج للسكين surface اللي فيه low solubility. طيب. Water soluble bases are mainly composed of polyethylene glycols. Polyethylene glycols are also called macrogols or carbowaxes. This S in the end of polyethylene glycols, macrogols, carbowaxes, this plural S because these substances have different molecular weights. And when we use polyethylene glycol, you have to specify the molecular weight you use by writing it next to the statement polyethylene glycol. So you said, I'm using polyethylene glycol 400. This means that I'm using polyethylene glycol, which molecular weight is 400 or 4000. or 1500 وهكذا. Polyethylene glycols are polymers of ethylene glycol. This is ethylene glycol. This hydrogen ion can be substituted with another molecule of ethylene glycol and further substituted many times according to the number of units of ethylene glycol in the molecule of polyethylene glycol. Its molecular weight is determined. The number of units of ethylene glycol in the molecule of polyethylene glycol determines the molecular weight of polyethylene glycol or macrogol, and also called carbo. Polyethylene glycols have unique properties. They have different molecular weight, as we said before. Polyethylene glycols of molecular weight from 200 to 400 are liquids, from 400 to 1500 are semisolids, and those from 1500 to 600 molecular weight are waxy solids. So you can use blend of these PEGs or polyethylene glycols to control the viscosity of the base, as we said before for petrolatum base. So the different molecular weights of polyethylene glycol gives us the ability to viscosity control. We usually use waxy solids. They have suitable melting and congealing temperatures, as we said before. These substances resemble fats in being of suitable melting point, not very high melting point, and they congeal at room temperature, so they are suitable for being an ointment base. The third unique property is their polar structure, which makes them water soluble, so easily washed, and many drugs can be incorporated in it, and the different advantages we said before. So the unique properties of polyethylene glycols are they have different molecular weights, so we can control the viscosity of the base. They are of suitable melting point and congealing temperature, so they are good for ointment preparation, and they are of polar structure, so they are water soluble. Now we finished studying the different ointment bases: oleaginous base, absorption base, water miscible base, and water soluble base. Can you correlate between different ointment bases? What did you notice in the composition of different bases? I myself noticed that all bases have oleaginous substance. Oleaginous base is included in all ointment bases except water-soluble ones. So from oleaginous ointment base, I can prepare, for example, anhydrous absorption base by adding lipophilic emulsifier. So you get anhydrous absorption base. To convert this anhydrous absorption base to water in oil emulsion absorption base, you just add water. So if you add lipophilic emulsifier to the oleaginous base, you will get anhydrous absorption base. If you add water to anhydrous absorption base, or actually if you add lipophilic emulsifier and water to the oleaginous base, you will get water in oil emulsion absorption base. طيب, can you prepare water miscible base from oleaginous base? Yes. Just add hydrophilic emulsifier and water to the oleaginous base, then you will get water miscible base, which is oil in water emulsion, as we said before. So there is certain correlation between different ointment bases, except water-soluble bases. We can prepare different ointment bases starting with oleaginous base. There is another system for classification of ointment bases, and in fact this system is an old one and it is no more used. They classified ointment bases according to water content during preparation, not hydrophilicity as we said before. No, during preparation, how much water you add to the base. They classify the bases into water-free bases that contains no water, formed only of oleaginous substances. This is also called anhydrous bases. And water-containing bases that contain some water. And as we said before, we are talking about ointments, so water content should not exceed 20%. Water-containing bases are called hydrous bases or emulsion bases because the water found in the base forms an emulsion, either water in oil emulsion or oil in water emulsion. Examples of water-free bases are oleaginous bases and anhydrous absorption bases. These two bases, we do not add water during preparation of the base. An example of water-containing bases or hydrous bases or emulsion bases are hydrous absorption base, which is water in oil emulsion, and water miscible base, which is an oil in water emulsion. This system of classification, in fact, it will help us in choosing the method to prepare our ointment base. So we said to choose a suitable base, one should know types of ointment bases, and we finished discussing this item. You also should know factors affecting the choice of the base. There are different factors affecting the choice of ointment bases. They are classified into dermatological factors concerning with the skin, pharmaceutical factors concerning with preparation of the base, and therapeutic factors concerning with the use of the base by the patient. First, dermatological factors. Dermatological factors that can affect the choice of ointment base are compatibility with the skin. Of course, the chosen base should be compatible with the skin. The used base must be non-irritant with a suitable pH value. We said before, suitable pH value for creams is from 4 to 7. Optimum is 5.5. So we are talking in the same range of pH value. Also, the base should be suitable to the site of application. As we said before, the site of application may be a dry area or an area with exudate. If the site of application is an area of exudate, you should choose a suitable type of base. Suitable type of base for area of exudates are those with no occlusive properties. Never use an occlusive base on areas with exudates. And also, the site of application may be a hairy area or non-hairy area, and we said that oleaginous and absorption bases are of relatively high fat content, so they are not suitable to be applied to hairy areas. at the scalp, for example. scalp اللي هي فروة الراس. Also, among dermatological factors is the effect of the base on the skin. The base may contain emollient effect, may exert emollient effect or occlusive effect, so you should take into consideration the effect of the base on the skin. This is about dermatological factors. What about pharmaceutical factors? Pharmaceutical factors affecting the choice of ointment base are the nature of the base. The nature of the base affects the ease of preparation of the base. Is your base an emulsion? Is it an anhydrous base, a water-free base? The nature of the base affects the ease of preparation of the base. Also, pharmaceutical factors include drug solubility. When the drug is soluble in the base, is highly soluble in the base, the drug incorporation method is easier, of course. And the drug stability. When the drug is liable for hydrolysis, never use a base with water in its composition. Use anhydrous bases with no water. Use either oleaginous base or anhydrous absorption base. For drugs liable for hydrolysis, avoid bases containing water. And among pharmaceutical factors is also drug compatibility. Choose a base that exerts no physical or chemical interaction with the drug. It's logic. And patient compliance. Patient compliance, to make patient use this base easily. So you have to choose a base which is easily removed and on application it's of suitable viscosity. Do not use a base of high viscosity so the patient cannot spread it. And do not use a base with very low viscosity so it has no residence on the skin. ما تقعدش على السكين أو ما تثبتش على السكين. You should choose a base with suitable viscosity and easily removed عشان البيشنت compliance اللي هي راحة البيشنت. Pharmaceutical factors affecting the choice of ointment base are the nature. Therapeutic factors include the required rate of drug release. We've mentioned before that the high solubility of the base of the drug in the base decreases the amount of the released drug. Here we mention that the higher solubility of the drug in the base increases the rate of the release. For fast release, choose a base with high drug solubility. What? You said before that high drug solubility gives poor release of the drug. Yes, poor release means the amount of the drug released is small, but this amount of drug is released in one rate. In what rate? In what speed? The rate of release of the drug increases as the drug is more soluble in the base, because the high solubility of the drug in the base enables you to add more drug to the base, to add more drug to your ointment, because the drug is soluble in the base. And this high concentration of the drug exerts concentration gradients. This high concentration makes the drug released fast, regardless the amount of drug released. Whatever the amount of drug released, it will release fast when the drug has high solubility on the base, in the base. So for fast release, choose a base with high drug solubility. Of course, high drug solubility of the base will decrease the amount released, but it will make it fast. It will make this the release of this small amount fast. So use suitable drug concentration so that the amount of drug released is suitable and the rate of drug release is suitable. كلام مفهوم؟ احنا قلنا قبل كده ان انا كل ما ازود السوليبيليتي بتاعت الدراج في البيز، كل ما استخدم بيز بتدوب الدراج اكتر، الاماونت ريليز بتاعت الدراج هتبقى قليله، الدراج مش هيبقى عايز يسيب البيز دي ويحصل له ريليز منها. كويس، ده كده الاماونت. انما احنا هنا بنتكلم على الريت. الريت يعني سرعه او معدل او السبيد اللي بيخرج بيه الدراج من البيز. كل ما كان الدراج soluble في البيز، كل ما قدرت احط كونسنتريشن اكتر من الدراج في البيز. الهاي كونسنتريشن ده بيعمل كونسنتريشن جريدينت، بيدي قوه دافعه للدراج انه يخرج بسرعه، مش بكميه كبيره، بسرعه من البيز. يبقى ال high concentration of the drug in the base due to high solubility of the drug in the base result in release of small amount of the drug in fast rate. Okay. For slow release, of course, so choose a base with low drug solubility. Now, we finished discussion on ointment bases. Another component of the ointment is additives. Additives are added to ointment either to exert their action in the fatty components of the ointment as antioxidants. Antioxidants do their action in the fatty components. They prevent oxidation and rancidity of the fats. And if your cream or if your ointment base is water containing or hydrous ointment base, you should add additives for water phase. They were co-solvents, humectants, preservatives, and buffers, as we said before in the creams. So we finished discussing definition, uses, advantages, and disadvantages of ointments and formulation of ointments. Now it's time to discuss how to prepare ointments. Preparation of ointments. There are two methods for preparation of ointments, and the choice of which method depends on the nature of the base. Do you remember the old classification of ointment bases? They classified ointment bases into hydrous and anhydrous. And we are talking about ointment base because we know that an ointment is composed of an ointment base containing the drug. So, to prepare an ointment, first prepare the base, then incorporate the drug in this base. To prepare the base, as we said, the method used depends on the nature of the base. We have anhydrous bases, they are water-free bases, and we have water-containing bases, which are hydrous or emulsion bases. The preparation of water-containing bases, which are emulsion bases, the preparation method is the same used for creams. Both are emulsions, so we use the emulsification method previously described for creams. The only difference is the amount of water. But for water-free bases or anhydrous bases, we will use a method called fusion method. So fusion method is method of preparation of water-free ointment bases or anhydrous ointment bases. What is fusion method? In fusion method, used to prepare anhydrous ointment bases, melt fatty ingredients and take care not to overheat them. How to avoid overheating? As we said before, use a water bath and add ingredients with higher melting points first, then add ingredients of lower melting point. Then dissolve oil-soluble solids and add oil-miscible liquids and stir till cool. Avoid sudden cooling to avoid the formation of cold spots, as we said before, to avoid the sudden congealing of the uh, of the fats before being mixed with other ingredients of the base. This is fusion method for preparation of anhydrous ointment. Now we prepared the base. It's time to incorporate the drug in the base. The drug may be incorporated during the preparation of the base, either by adding it or dissolving it in the molten base, or if your base contains liquid paraffin. We said that liquid paraffin acts as viscosity controller، ده مش مهم دلوقتي، and levigating agent. So if your base is liquid paraffin or any liquid fat, you can use it to levigate the drug, add it separately to the drug, levigate the drug with this liquid fatty substance, and then add the levigated drug to the base to ensure good mixing of coarse powdered drug with the base. We may be asked to add the drug to the base with the drug is finely powdered, so you can add it after preparation of the base using trituration method. Just take a part of the prepared ointment base, non-medicated ointment base, and then triturate the drug with it. We can use trituration because here we are talking about a drug with fine powder structure. When you triturate the drug with some of the ointment base, the produced the produced portion of the ointment base is called concentrated ointment. Then you can add this concentrated ointment to the rest of the base and triturate it with the rest of the base to give medicated ointment. This is the trituration method. The ointment, here the ointment base was prepared either by fusion method or emulsification method, but the drug was incorporated in the ointment base using trituration method. For eutectic drugs, use trituration method. Take some of the previously prepared ointment base and put the two eutectic mixtures together. We said eutectic mixtures are solids. When mixed together, they give a liquid. So mix the two eutectic solids together to give a liquid. Then triturate them with some of the base to form the concentrated ointment. Then add the concentrated ointment to the rest of the base to form the medicated ointment. Here we come to the end of our lecture. The end of this lecture You are supposed to be able to predict a suitable base for an ointment to differentiate between the four different types of ointment bases, to list factors affecting choice of ointment bases, to predict a suitable method for the preparation of, of an ointment, either ointment base or incorporation of a drug in an ointment base. By now, we have finished ointments. Now,